Assalamualaikum everyone. In today's video, we'll be discussing topic salt preparation. This topic is of O levels chemistry, and the code for O levels chemistry is 5070. So let's get started. Firstly, to do the questions of salt preparation, you need to memorize the 7 solubility rules. The first one is that all group 1 salts are water soluble. Second one is all ammonium salts are water soluble. Third one is nitrates are water soluble. Fourth one is that halides are water soluble except silver and lead halide. Fifth one is that all sulfates are water soluble except barium and calcium and lead. Sixth one is that all carbonates are insoluble except group 1 and NH4 means ammonium. And all halides are insoluble except group 1 and barium. So these are the 7 solubility rules that you need to memorize for this chapter of salt preparation. So let's move on to the next topic, which is salt preparation. Firstly, you need to remember that which compounds are water soluble and which aren't. So the one that are water soluble, for them there are two methods to prepare salt. First one is preparation by acid base reaction. If the cation is other than group 1 and group 4, this is the one condition. For example, you are given any compound or any question that have a compound. Firstly, you need to see that if the cation is from group 1 and or is NH4, so you will go towards the titration method. But if it isn't from the group 1 or NH4, so you will do the acid base reaction method for preparation of the salt of that compound. And if the compound belongs to group 1 or NH4, so you will do titration method, which is method number 2. And the condition for this is that if the compound belongs to group 1 means sodium, lithium, and potassium. And if it is NH4, you will do titration. Now for insoluble salts, what you will do, the preparation insoluble salts are prepared by precipitation method. So let's look at these methods. First method, preparation by acid-base reaction. There are 3 acid reactions. First one is metal plus acid gives salt and hydrogen gas. So hydrogen gas is in gas form and the salt is in aqueous. However, the metal is solid and the acid is aqueous. The second reaction is metal hydroxide plus acid gives salt and water. Water is aqueous, salt is aqueous, metal oxide is solid, and acid is aqueous. Then the third reaction is metal carbonate plus acid. Metal carbonate is solid, acid is aqueous, which it gives salt, which is aqueous, water, aqueous, and carbon dioxide, which is gas. So, for example, you are given a question that preparation, write the procedure to prepare for the preparation of zinc sulfate. Usually, this question appears in P2 for 3 to 4 marks, and sometimes may appear in P1 also in MCQs. So in MCQ paper, you do not need to write. You have to just tick the correct option. But in P2, you have to write this method. Preparation of zinc sulfate. So now let's look at the cation of this compound, which is zinc. Zinc do not belongs to group 1, neither it is a ammonium salt. So zinc is a metal, but it doesn't belongs to group 1. So we will use the method of preparation through acid reaction. You can choose any one of the acid reaction. I have choose that metal plus acid. Metal is zinc plus acid, which is sulfuric acid. I have to thicken gives salt, which is zinc sulfate, and hydrogen gas. Now, what is the procedure? So, firstly, you need to take acid, which is H2SO4 or sulfuric acid, in a beaker and heat it, and add excess metal, which is zinc. Now, remember one thing, that you need to add metal in excess. Why? Why you should add metal in excess? Metal is in excess so that all the acid is used. Sometime in P4, this type of question occurs, that comes that why acid must not be in excess. So this is because that acid is a toxin and it is corrosive. And if the acid is in excess, so the final product may be pollutant due to excess acid. And secondly, acid is difficult to remove from the solution. However, the metal should be in excess metal oxide, metal or metal carbonate because it helps you to identify the completion of the reaction as all the metal would be dissolved in that acid. So remember one thing for this, that metal should be in excess. Now next thing what you need to do is add excess metal, which is zinc. The metal you have taken is zinc. Once it stops disappearing, filter the solution to remove it. Remove the excess zinc. So when the zinc has been dissolved and the reaction has been completed, uh, you can say fizzing would be stopped, and you by this you identify that the reaction has been completed. Now you will filter the solution to remove excess zinc, and when you and the filtrate would be aqueous zinc sulfate. This is the salt which is filtrate, aqueous zinc sulfate. Now you have to take the filtrate in an evaporating dish and heat it up to saturation point. This is the keyword, heating up to saturation point or crystallization point. Then once the saturation point reaches, allow it to cool as the crystal appear, filter to collect crystals as residue. Now when the crystal appears, you need to filter it to collect the crystals as residue. Then you have to wash the crystals using organic solvent or distilled water and dry using sandpaper. So this is how you obtain the pure crystals of zinc. Now the second preparation is of NaCl. NaCl is, now you can see that Na means sodium. It belongs to group 1. We will do titration. So what is titration? Firstly, you need to remember the definition of titration. Usually it may appear in P1 as well as MCQ, and they may ask you that what is titration, and in P2 for 1 marks. So titration is to find out the concentration of unknown solution using a known solution. This is known as titration. So the apparatus needed for used for titration are burette, pipette, conical flask, iron stand, funnel, pipette filler. These are 1, 2, 3, 4, 5, 6 apparatus you need for titration. Usually this titration question comes in P4 sometimes, and they may ask you to, this may come for 6 to 7 marks in the last question of chemistry, and they ask you to design an experiment for the preparation of salt. It isn't given that you have to do titration. The salt name is given, and you need to tell, or you need to identify that which method is going to be used. Okay. So firstly, what you need to do is to take 25 cm cube. So this 25 cm cube is taken by the pipette, because pipette is the perfect apparatus for measuring 25 cm cube volume. So you have to take this NaOH, which is base, in a conical flask through pipette. Remember one thing, that always take unknown solution in a conical flask. Then you need to add a few drops of suitable indicator. There are two indicators in our syllabus. First is thymol pethylene, and the second one is methyl orange. So add a few drops of suitable indicator and fill the burette with HCl up to mark. You need to fill the burette with HCl up to mark. Now thymopethylene is an indicator that you can add, and it is in our syllabus. In acid, thymopethylene get colorless, and in base it gets blue. You need to remember this. Thymopethylene. It is an indicator. It indicates that whether the solution present in the conical flask is an acid or a base. Now open the tap and start adding the acid from the burette. Acid is in the burette, and burette burette measures 50 ml or 50 cm cube of volume, and the smallest division of burette is 0.1 ml or centimeter cube. On the tap and start on Open the tap and start adding acid from the burette into the conical flask until the color change is observed. You need to add acid from the burette. Now discard the solution and repeat the process without using the indicator. Now this time you have to repeat the same process, same volume of acid should be added, but this time you don't have to use the indicator. Okay, sometimes it may come in P4 question, like for 1 to 2 marks, that which other method you can use to do the same titration without repeating it without indicator. So for this, you can add a carpol. Let me write it. Carpol. So this carpol is something that when you add it to the titration, instead of discarding the solution, you add this carpol in it, so it absorbs the impurities and the the solution. You don't need to repeat the this titration again. So you can add this carpool in this because it absorbs impurities, and the impurity is that indicator. Okay, now you have to repeat the same method of crystallization. What you have to do is to take the filtrate in an evaporating dish and heat it up to saturation point. Once saturation point reaches, it allow it to cool as crystal appear. Filter it to collect crystals as residue, and then you have to wash with organic solvent or distilled water and dry them using a sandpaper. And this is how you obtain the pure crystal of sodium chloride. Okay, let me show you image of burette, pipette, and conical flask so you can have a better understanding of this. So let me share the screen. I hope it is visible. So you can see the in this image, this one is burette. This is the burette. This is the tap, and this from when you open the tap, the acid in present in the burette starts falling into this is the conical flask, and this is the you can say base present in the conical flask. This is a dropper, and this from it you take the indicator from the container and add indicator into this conical flask, and this is acid present in this. And let me reshare my screen. There is another image. So I hope it is visible. This is the pipette and this is the burette. Sometimes four images or four pictures come in P1 and they ask you to identify which is burette and which is pipette, and sometimes they may ask you that identify that which one is used for the titration and which one is used to hold the volume. So burette measure volume of 25 cm3. However, no, pipette measure volume of 25 cm3 and burette measure volume of 50 cm3. So I hope you understood it. Thank you.